So hello, my name is Eduardo, Ariño de la Rubia, and I'm going to be talking about developing and deploying models at scale without Spark. And I'm also going to be talking about some other things with some feedback. So real quick, I wanted to humanize myself before I dehumanize everyone else. So this is my lovely wife. She's the one in the relationship with the doctorate. I do not have one, even though I'm the chief data scientist of a company, so noodle that one. Those are my 3 dogs. I really wish Alexei would have asked me to come talk about dogs and how awesome dog training is, but he didn't. So here we are talking about building models with Spark. And on the left is my very first computer. It's a Sinclair ZX Spectrum, which had 16 roaring kilobytes of RAM, literally everything a burgeoning data scientist in 1982 could possibly want. Just a little bit more about myself, a little bit more self-promotion. So I've been doing this for a really long time. I wish I would have known it was going to be called data science, because that's a way cooler title than like nerd who likes math, which was what I called myself for about the first 15 years of my career. I got my first account on a supercomputer in '96. I hired my first machine learning engineer in 1999 because I was really convinced that if you took customer buying data and you like rammed it through machine learning, you could do interesting things with it. I was right. Obviously it didn't work out because I'm here talking in front of you and I have a job. So like I obviously like didn't cash out on it like I should have, but it turned out okay. Since then, I've done a lot of things, lots of real measurement science in manufacturing and logistics and robotics. Started using Domino in 2013 and became the chief data scientist in 2015. I was literally just a user and advisor for the first couple of years. Are you giving me the timing cues? Okay, excellent. Real quick, I'll try not to do much product pitch, but it's literally my job, so I have to do some of it. So Domino, it's an open platform for data science. Our real target is like if you've got a team of data scientists and you want more and you need to scale what your data science team does, we do that real well. You get to use the code you already like and the languages you like. I think we would have failed if we tried to invent a new statistical programming language because there's already brilliant people doing that. You get to get data however you get it today, and you get to use like the best tools, like RStudio is a really fantastic IDE for R, or like H2O is the definitive machine learning library. Like you should get to use those if you're a data scientist. And we add a whole bunch of stuff to it, like compute automation and environment management, and I'll go a little bit into what that is, and you'll just see it in my live demo, because that's what I was asked to do as a live demo. So I'm going to build and deploy a machine learning model. I'm going to be using H2O.deep learning as the first thing that I'll do on an X1 instance. And I'm going to build and deploy an X1 model on 10 million rows with 128 cores. Hopefully that wasn't what happened already here today. But so real quick, this is one of my favorite slides of the data science process. It was written by a guy named Dr. Szilárd Pavka. You should look him up. His work is just fantastic and stellar and quantitative. We're going to pretend like understand, collect, explore, vis, clean, and transform are just easy. We're just going to go ahead and pretend like those are not the hard part of data science and artificial intelligence. They are. They're really, really hard, and that's the part where you get into arguments, and that's actually why I'm doing a master's degree in negotiation and conflict resolution, because that's literally constant negotiation and conflict resolution. We're going to focus on the modeling component, and one specific thing I want to say is that this is Szilard's model, but on the bottom right is a thing called CRISP-DM. Just by a show of hands, who here is familiar with CRISP-DM? Okay, a few hands. It's the cross-industry standard process for data mining, which data mining is like, ooh, gross, data mining. Turns out like the same set of problems were solved a long time ago, and they invented this cross-industry process. You should, if you're doing data science-y, AI type work, you should probably be following it. So we're going to build something, and this is what it's going to look like. We're going to pretend like building an AI model. Building a model is the hard part. We're going to use up 128 cores. We're going to use up 2 terabytes of RAM, and we're going to do it on one machine. And to leverage a little bit more of Szilard's work, it's, you probably don't have big data. Like just sampling across all of you here, like there's probably like 4 or 5 of you that actually have big data. But data sets are increasing in size about 20% year over year. That's based on a KD Nuggets poll. While in the same exact period of time where data sets were increasing, and this for analytical data sets, were increasing 20% year over year, the amount of RAM available inside of like single instance machines was actually increasing 50, 60, or 70% each year. I mean, it's not so hard to figure it out. You used to be able to get a box with 16 gigs of RAM on AWS, and now you can get a box with 2 terabytes on RAM on AWS. That's a significant increase. before I go into my demo, there's a great quote, if you were plowing a field, which would you rather use, 2 strong oxen or 1,024 chickens? And this was Seymour Cray's famous quote. And it was funny because during the late 90s and early 2000s, we all felt really, really smug because we were like, oh no, it turns out that you want to use 1,024 chickens. Maybe Seymour was onto something because give me a choice, I'd actually use 128 oxen than pretty much an infinite number of chickens. So just a couple of things. We're also going to deploy a model in my demo. So I'm going to literally just build using H2O's deep learning on the airline data set. I'm going to build a deep learning neural network. And then I'm going to deploy it as a RESTful API. And it kind of cracks me up. I keep hearing people be like, you can't use R in production. And then I'm like, oh, you can? Have you tried? They're like, well, no. And then it's like, well, okay, so we're hiring a bunch of Python people. Why? Well, because we want to use Python. And immediately they're like, but I've heard that Python is too slow for real production anyways. And then that's not true either. Then you hear that people are like, oh, it's really hard to port models to Scala or Fortran or C or whatever we actually run in production. It really doesn't have to be that way. You can just port the model. So let me get to my live demo real quick. Let's see if this works. Can y'all see my screen? Okay, so let me make the font big enough that humans can see it. Okay, that's good enough. All right, so we're gonna go, so this is Domino. Domino's a web-based platform. Inside of here, whenever you land inside of a project, you can think of it as sort of like your contextual notebook. Each one of these executions happen in a fully isolated container, and it's nice because you can see the code that executed and you can reason about it. Just to look at the file itself, I have this file called train.r, which is actually taken directly from Szilard's repo with just small modifications. Basically, we're actually only going to use 50 gigs of RAM, so we're actually not even using that much RAM. I'm just going to go ahead and execute this to spawn this thing off. All right, so while I'm spawning that off, let's look at the file real quick. Right, so import some files, do a little bit of normalization, train a deep learning model, go ahead, get some performance metrics because you want to know how fast, what the performance is. Go ahead, delete the old model, save a new model, create a diagnostic list. While this is going on, hopefully I caught it in time. I'm going to go ahead and copy this SSH command over to this terminal. I'm going to SSH over here. And this is pretty cool if it'll work for me right now. I mean, that's 128 cores that are processing away right now. Again, this is there is no weird inter-node communication. It's not super duper slow. I didn't have to worry about loading data inside of RDDs. I didn't have to worry about did my EMR cluster get screwed up because my Kerberos key got stomped on. I'm literally just using open source R and the open source H2O library, and I'm leveraging 128 cores to train a deep learning neural network model. And what's really cool, I don't know if you can see this right here. Each thread's been executing for 25 seconds, but the main thread's has an hour and 10 minutes of processing already assigned to it, right? Because the way process trees work inside of Linux, the parent process gets all the time for all the child processes. So this is just happening right here, which is pretty cool. If you look at a lot of analyses, the average size of the average Spark job is 60 gigs. 60 to 100 gigs. If you do the math, you can fit 20 of those on an X1 instance. And why are you paying the weird cost of spinning up instances and RDDs and dealing with Spark and Scala when you're AI people would rather just be using Python, or they'd just rather be using R. Unless you have a really, really compelling use case for why you need to pay the weird penalty, I'd really suggest you didn't. So that's going to be done here in just a second. Yeah, so it's got about, it's funny how 2 minutes and 30 seconds feels a lot shorter when you're preparing a talk than when you're standing in front of all of y'all waiting for it to train. So this will be done here in a second, and what it's going to do is it's going to actually spit out a model. And I think I showed you in the code where that's going to be. I'll just go back to say it. Here's where I just remove any old models, and here's where I save the model. One thing that's nice about Domino is that Domino has fully automated version control, so literally every time you modify the file system, we keep the deltas. So even if in my code I'm deleting the model, at any point in time I could just, or actually I'll just go back and show you, here's what it looked like at 3 o'clock. These are all the times I was testing this to make sure it would work, right? So I could go back in time to any of these, and I can literally see the entire project state at that time. So that's a nice thing about having everything run inside of a single centralized system of record. So, okay, so it's done, it trained it. I could look at the code, right? I can see any diagnostics. Here's the AUC. I went ahead and plotted it. H2O does a nice job of making like their models nicely plottable, right? So like it just kind of all works with R. You don't have to like worry about any weird like Spark plotting libraries that I don't even know if those exist. So let's go ahead and like publish a model. So in Domino, we just go to models. And so I'd already pushed a predict delayed flights model. So this is our new model management system. This is actually literally the first time that has been shown to anyone who isn't a Domino employee. What we basically let you do is we let you take any code. Here, I'll publish a new version real quick. So here I'm using the airline model project. That's the one I was doing in. It's like trained this in front of people. I am terrified right now. And let's see. So I don't need the data set, right? I literally just need the model file and a file called API.R. And it remembers that there's a function called API. I should have shown you that. Ugh. Ed, chill out for a second. So to show you what it takes to actually publish it is really straightforward. So I created a file called API.R, and it just like calls the H2O library, loads dplyr, initializes, sets no progress bar. It's actually funny, printing out a progress bar takes a surprising amount of time. And then I just declared a function. So this is all R code, right? And I just said there's a function that takes a list called data. It has these parameters in it. I create a new H2O data frame. I predict, I turn it into an R data frame and return the prediction. Like there's no resty stuff in here. There's no like magic in here. This is just like straight up good old fashioned R code. And so here I tell it it's in a file called API.R. It's a function called API and publish. So it's building, it's starting, and it should be, I like that it says build building. I'm going to make fun of them for that. So it's succeeded. So what Domino does is it actually like creates now a Docker image that is like a serialized Docker image so that like, let's say that you're a bank and let's say that your models like were denying loans to people of color an awful lot and like a regulator shows up and they're like, hey, can you prove that like this, like your model isn't racist? That's hard. Proving your model isn't racist like is actually like kind of a challenging thing. And yet I think that as data scientists, like we all need to do that. I think we all should be really, really focused on proving that our models are not like sexist or like misogynistic. So one of the nice thing that Domino lets you do is it lets you go, hey, Mrs. Regulator or Mr. Regulator, I can go back to the project, I can go to the exact commit and show them the code that trained it. So that's all there. So it's been, model succeeded. Let me go ahead and deploy the version. So I'm going to go ahead and deploy it. Just to show y'all, there's all kinds of nice functionality we've added to auto scale, so we can set like the hardware tier, set the number of pods. This new model management framework leverages Kubernetes. I don't know if y'all have heard about Kubernetes, but it's just a really, really nice way of like managing fleets of Docker containers. I have no idea what threads per pod does or anything like that, but I'm sure the tech people know. So here we are, we have this model, and I'm going to go ahead and call it. So did I close my Xterm? I did. What a goofball. All right, so I created a little Perl script because I'm very, very old, and I still write Perl. And so it's just a Perl script. It goes through the same airline CSV file that I trained, and just goes ahead and calls on curl, right? So our model, let me go ahead and close that. Our model just takes data as a JSON parameter. So let me go ahead and call that. So clear Perl call airline. All right, there we go. So it's you can tell, every time it updates, that's the number of milliseconds it took to respond. I could deploy a new version and it wouldn't drop any connections. So this is like R in production. Anyone who's ever been like, oh, you can't like put R in production. You can put R in production, it works fine. You just need to like build a DevOps harness around it. And like you can build your own DevOps harness or you can use Domino. There's like lots of really fantastic options out there. So let me see. So I have a few more minutes, but that's basically the meat of my talk. The meat of my talk was supposed to be deploying a large model without using Spark. So what have we done? We've trained a deep learning neural network. We're using a box that has 128 cores. We have trained it, we've deployed it in production, we're hitting it with a REST API. I didn't need Spark, I didn't need any languages other than languages that data scientists know and love. So that's the first part of my talk. Fortunately, I prepared more talk, because otherwise y'all would have nothing to do for the next 15 minutes. So hey, this is an AI conference, right? AI is cool. but what if it's coming for you? Have you heard of this guy, Randy Olson? Has anybody here heard of Randy Olson? Okay. Hey, I know you. Hi. So Randy Olson is fantastic. He's, if you've ever heard of the subreddit Data is Beautiful, he's one of the moderators of Data is Beautiful. And he's created a piece of software called Teapot. Teapot is a automated machine learning tool. That being said, so I'm actually giving a talk at Strata about automated machine learning tools. H2O is coming out with one that I'm just super hyped about. This is just the one that was currently released that I could show you right now. So what Teapot does is you give it a data set, you give it a target column, and it actually like genetically evolves an entire machine learning pipeline for you. You don't really need a data scientist or anything like that. So I'm gonna go ahead and just do that. So let me go ahead and spin this up. I'm gonna rerun this because it's important to actually like show y'all stuff running instead of promise that it did run at some point. So here it is, it's spinning up inside of Domino. Let me go ahead and secure shell to the box. This one is not as exciting as H2O. It doesn't use cores nearly as effectively. I mean, it does all right, right? You like see some usage, but then like the usage will drop off. It's not as good, but it still does a pretty good job. Honestly, it's hard to beat how well H2O does this particular job. So what's happening right now is Teapot, let's actually look at the code. It's just this much code. So basically you create a Teapot classifier, you import the Teapot classifiers, you read your data set, and for this I'm using a real small data set because I want it to be done in a minute and a half. So I'm literally going to evolve an entire machine learning pipeline from data and then deploy it as a RESTful web service in about 2 minutes, right? So it's just a small data set. It's the Pima Indians diabetes data set. It's just kind of one of the classic UCI data sets. I'm saying, hey, this is the column that I want. Do a test train split and create some kind of classifier. I don't know what kind of classifier it is. You can use 120 cores. There's going to be 10 generations of them. And go ahead and actually like fit it. And then from there, it actually is going to print the score, and it's going to export the pipeline. So I'm not doing any machine learning, right? I'm not actually like doing any feature engineering. I'm not doing any of those things. I'm literally just saying, hey, Teapot, here's a column, here's a data set, here's an X1 instance that has 128 cores and 2 terabytes of RAM. Just take a while and evolve a machine learning pipeline for me automatically. This doesn't mean that like the data scientists are going to be like out of a job tomorrow, but this is something that's important to be aware of. The bar is moving. One of the things that I'm going to talk about, not at this talk, but in a future talk, is that the bar for automated machine learning keeps moving. When I started doing machine learning, you just like downloaded some C code of some like dude's FTP repo, and you like compiled it and hoped it turned into an R2 network. And then we like got Carrot, and that was amazing because like it did all the resamples for you. And then we got H2O, which is incredible because it does like this grid search for you, and it like finds the absolute best hyperparameters. And like now there's these things that are coming out like Teapot or like the AutoML stuff that like the bar is moving, and I'll talk about that here in just a second. So here we are, so it's calculating the different generations. This is what I love about live demos. In the previous one, you'll notice it took 1 minute and 24 seconds, 52 seconds, 1 minute and 51 seconds. Here we are at 2 minutes and 30 seconds, and it's not quite done yet. So my timing was a little off. Okay, excellent. So it figured out that for this data set, it turned out that linear support vector machine with hinge loss function with L2 with this was the one that it found that was the best one. And it actually like generated it as code for me. Like here it is. Like here's the code. It does the train test split. It exports the pipeline. It fits it. And then I just wrote a little wrapper that adds this little bit of code, this API features. So let's go ahead and publish this. So I can go to models again, go to the Teapot model versions. Let me go ahead and publish a new version. This one, I just pushed some buttons and the AI did it for me. And yeah, I do want the data in this case because it trains the model upon deployment. Teapot just generated the pipeline. Here is the pipeline, and I go ahead and publish. And building, starting, again, it's making the Docker image, and we can even look at the audit logs. We can see that a new version was created. I'm the one who created it. Build is successful. Let me go ahead and deploy the version. And all right, while that is deploying, I'm going to go That's not a good window to show. This one. All right, clear, reset. What did I call it? Oh, yeah, so I have another script, another Perl script, because I'm old again. Teapot, pipe through more. And it does the same thing, only this time it calls the URL for the Teapot web service. And there we go. In this particular case, it's much, much faster. If you remember, the previous one was a couple of 100 milliseconds per score. A deep learning neural network is a much more complicated thing than a support vector machine. But here you are. I as a data scientist, I didn't build this model. I didn't train this model. I just uploaded some data into a thing. I pushed a couple of buttons, and it built the model, built the classifier. It deployed it for me, and now here it is, and anyone could access it. So, yeah, so I'm rapidly automating myself out of a job, which is pretty cool. So I've got a few minutes left. I was going to take this opportunity to talk to you about completely different things. Hey, so this is an AI conference, and so my wife has a doctorate in education, and particularly in curriculum design, and we get into humongous loving arguments at my household about whether AI can learn anything from education. The answer is yes. It's been explained to me that yes, we can. And there was 3 points she wanted me to make, is that people working in AI need to understand how assessment really works, and we need to understand that there's 2 types of assessment. There's a formative assessment, and there's a summative assessment. When you're creating machine learning models, artificial intelligence, you want to make sure that you're doing formative assessment during the learning process. The kinds of questions that you're asking are fast questions that you can answer real quickly, that you can sort of go through your hypothesis space incredibly quickly, so that you know that your learning methodology and your training methodology is pointed in the right direction. And then at the end of your deploy, you're going to want to do a summative assessment, right? That's when you actually you compare it against some standard or benchmark. If you're not doing both of these things inside of your sort of data science practice or artificial intelligence practice, then you're leaving some learning on the table. And I often see that data scientists and AI researchers don't do this. They primarily just do summative analysis and just look at diagnostic statistics and call it a day. The other thing I was going to say is Bloom's taxonomy is pretty interesting. Computer science has been stuck for the longest time at remember. That's what we focused on. We focused on actually having data structures that made it easy to remember a thing, and even simpler examples, the entire field of information retrieval. The entire reason y'all are here, I'm guessing, at ai.by.thebay is because you want your machines to start moving up Bloom's taxonomy. Right? You want them to be able to understand, apply, analyze, evaluate. And if you've looked at some of the amazing things that are coming out of the field of deep learning, even create, right? We used to think that creativity was sort of this bastion of human kind, that we would never be able to create machines that did it for us. And yet we're on that precipice right now. That's happening. So keep this in mind, both in the questions that you form yourself, in the hypothesis space that you search when you're building an AI, as well as what is the hypothesis space that you're asking your AI itself to answer. And finally, yes, curriculum, turns out it's a thing. Turns out that whenever you're training your AI on a data set, you're actually providing it a sort of a unstructured curriculum. That data is the curriculum. And that's the explicit curriculum, which is written, right? So in that data set, you're sort of pushing forth the ideas that the data generating process that is reality and the sensors that you had sampled and wrote it down, that is what you're training. But that's not all that there is, right? There's also the implicit curriculum. That is, that which is unwritten. This is the thing that's not going to be able to be replicated by others. You're not even going to be able to prove that it exists. This is, the canonical example is that if all your cops are racist, then all the data sets say that black people, commit more crime. Hey, maybe you just got racist cops and your data sets themselves are this mirror on the bias, and that's the implicit curriculum. I think we have a responsibility in this community to be aware that the implicit curriculum is larger than the explicit curriculum, and that we always have to keep a skeptical eye towards it. Then there's the null curriculum. That one's easy. That's the things you're explicitly not choosing to test. But if there's one thing that a lifetime in this space has taught me, is that the null curriculum quickly becomes your explicit and your implicit curriculum as you realize that the questions that you want to ask go higher and higher in Bloom's taxonomy. So hopefully that wasn't too terrible. We're hiring. If you know any Scala engineers, we've got lots of really cool, interesting problems, and we're hiring them like crazy. Yeah, our entire stack is written in Scala. Everything you saw is in Scala. So hit this website. And lastly, hey, thank you very much. And I hope you enjoyed that. Cheers. I'll do my best to provide a salient answer.
I just wanted to ask, and maybe I wasn't listening, I apologize. You had shown us this example, particularly with an airline data set. Can you speak a little bit more about what that data set actually was?
Yeah, the airline data set is like a canonical, fantastic data set. It's the ASA's 2009 data challenge, if I remember correctly. So it's a cool data set because it has it has numeric features, it has categorical features. It's a real world data set, and what it is, it's basically just like the takeoffs and landings of like millions of planes, and it's a big enough data set that you can't like non-trivially just sort of like blast it all into a thing and get a reasonable answer. But it's not so massive a data set that you can't like do some clever stuff and do like a demo where we trained on all 10 million rows like right here in 2.5 minutes using H2O. So it's a fantastic data set. Like if I would have shown you iris, like half your eyes would have rolled out of your head. You'd be like, oh, the iris data set. It's just a really good data set for figuring out on-time departures and that sort of thing. Cool. Any other questions? All right. Well, thank you very much again. Cheers.